Okay, so what I wanted to do was just do kind of a little bit of a quick review on some of the stuff in Unit 4. Um, you just went through and did the test prep / planning worksheet on taking stock of how you feel about the vocab and certain topics. And if you look back in your journals, we did do a concept map over thermochemistry. Thermochemistry studies the transfers of energy, and we defined energy as the capacity to do work, and that energy transfer of energy usually typically takes place in either physical or chemical changes. And we describe that energy change as it being exothermic if something releases energy or heat, and being endothermic if it absorbs energy or heat. Okay, so again, review of topics we should be familiar with. When we talked about energy, and it's going to include either potential energy or kinetic energy. Now, potential energy is stored energy. We don't really talk too much about potential energy in Chem 1. We did talk a lot about kinetic energy. Kinetic energy is related to the motion of particles, right? Kinetic means motion. And kinetic energy is also directly related to temperature, meaning that if one goes up, the other goes up. Okay? Now, when we talked about temperature, the two main scales that we mentioned were Celsius as well as Kelvin. Fahrenheit is what we use on a regular basis, and remember, to convert from Celsius to Kelvin, you simply add 273. It's a pretty simple conversion. Now, temperature actually indicates the flow of heat between substances, and it's measured by a device called a calorimeter. And when we did our food lab, we used a calorimeter for that. Okay, we also reviewed the types of math problems that you may see. You're going to get both of these equations. The other day we also talked about the curveballs that mostly relate to this mass value. Sorry about that. One of those curveballs was using the density equation to solve for mass, where typically you're given the volume and you're given the density, and to manipulate the equation you need to multiply both sides by v. So if you take volume times the density, you can get the mass and then plug it back into either one of these equations. The other one is if you're given moles of something. So if, let's say, we had 2.0 moles of hydrogen, we'd go to the periodic table, we find the molar mass of hydrogen, which is the one with the decimal place. You'd see that on the periodic table, hydrogen has a molar mass of 1.02 grams. We set that up so that we can cancel out the mole unit. This would allow us to figure out that we had, actually this would be 1.01, not 1.02. Okay, so if we take 2, since it's on the top, we multiply it by 1.01, would get us to 2.02 grams of hydrogen. We could plug that in as the mass and then solve as needed. Okay, now the new concept map that I want you to write down is over 4B. We'll come back to that one in just a second. And for 4B, really what we talked about in 4B was the kinetic molecular theory. Okay, and with the kinetic molecular theory, there are 5 main ideas or assumptions. You should be familiar with those. This relates to the fact that gas particles are very far apart, the collisions are elastic, the particles are in constant, continuous, rapid, random motion, as well as the fact that there's no forces of attraction, and the last one, which is the fact that kinetic energy and temperature are directly related. Now, the kinetic molecular theory is based on 2 main ideas, or 2 main sources of information. The first being the attractive forces between particles. Now, I'm not asking you to understand how they work or even why they exist, just that they are there and they cause things to, move or change in different ways. The other thing is, in addition to being based on the attractive forces, it's also based on the kinetic energy of particles. Okay, and as we've already talked about, the 5th main idea of the kinetic molecular theory is that kinetic energy is directly related, which we saw this on the last one as well, to temperature. Obviously, if we're writing it down again, it's a pretty important concept. So, it's directly related to temperature. Now, what the kinetic molecular theory does is it explains molecular motion. Okay, molecular or particle motion. Okay, kinetic means movement, molecular, and theory is an explanation. So the kinetic molecular theory is going to explain molecular or particle motion. And this includes all of the phases of matter that we're going to talk about, which includes solids, liquids, and gases. Alright. Now, solids we don't really talk a ton about, other than the fact that they are in a fixed position, and the only motion that they have is vibration. Okay, so you have these particles that are very close together. They're in a fixed position. They're not going anywhere. My circles aren't coming out very well, but the only thing that they happen is that they can vibrate back and forth. Now, for both liquids and gases, we also refer to these as fluids, meaning that the particles can slide past one another. Okay. Now, with liquids, there are two special properties that are unique to liquids that really were covered in 4C, but we can mention now anyway. And the two properties of liquids that are important are capillary action, which is where the surface of a solid is attracted to the surface of a liquid, as well as surface tension. And surface tension is when the particles on the surface of a liquid are pulled together and they kind of just create this barrier. Again, if you ever jump off the high dive, you've experienced this because all the water particles at the top are pulled together tighter, and therefore it's why it doesn't feel so great if you do a belly flop off the high dive. Now with gases, they also have some special properties, and mine's going to have to come down here a little bit, but the properties that are particular to gases include the fact that they can expand to take the shape of their container. Okay, and the reason that this happens is because the particles are very far apart, as well as the fact that they don't really have any forces of attraction and they're constantly moving. So that's why that happens. You also have the fact that gases have very low density. Okay, this happens because they are very far apart from each other to start with. You also have, which is kind of related, since they have such low density, gases are able to be compressed, or you take up some of that extra space between them. You also have the fact that they are fluid, which we already mentioned, but that's one of their special properties. And then lastly, you also have the fact that they can diffuse or randomly mix with one another. And this really is because of several of the reasons of the kinetic molecular theory. They're far apart, they're in continuous rapid random motion, they don't have a lot of forces of attraction, and the collisions are elastic. So all of those relate to diffusion. So here are just some of the main ideas with kinetic molecular theory and kind of how they tie together. Again, the two big things with kinetic molecular theory is that it's based on the kinetic energy of the particles and the attractive forces. Which leads us to our last concept map that we did in our notebooks the other day. And this is looking at the three phases of gases, liquids, and solids. And remember, we purposely put the liquids and the solids a little closer together because these two states of matter really aren't that much different. The liquids are the particles are a little bit further apart. The attractive forces are less, so that's why they can slide past one another. Really not trying to change my color scheme here. But to make the jump to gases, gases are about 1/1000th the density of liquids and solids. So you're talking about a big jump when we get here. Remember, we kind of had this continuum out to the side of kinetic energy and temperature that are higher for the gases and lower for the solids. And then on the flip side, if we have higher kinetic energy and higher temperature, you have very low attractive forces. Okay, and those are going to change as we go, if we think about going down the scale this way, where for solids you have your lower kinetic energy, your lower temperature, but your higher attractive forces. Okay, and liquids are in between there, where the attractive forces are strong enough to hold the liquid particles together, but weak enough that it allows them to slide past one another. And the other thing that we did is we categorized all the phase changes, where everything on this side that flows up is endothermic. Okay, so whether that be melting, sublimation, vaporization, boiling, or evaporation, those are all endothermic and require an input of energy. Everything on this side is going to be exothermic because energy is being released, and that's going to include condensation, freezing, and deposition. Okay, so again, just a quick review of the big major concepts. Alright, in a minute here, the sub is going to take you to the computer lab. First and foremost, the first thing that you are going to be working on is the gizmo. This is due before you leave today. So some people are going to get right to work. They're going to have no problem. They're going to get it turned in. I am going to be looking at it for accuracy, and they're going to have followed directions and done well. If you choose to not stay focused and not get as much done, everyone else has most of it done and you have 3 questions, don't be prepared to get a very good grade. Okay? Hopefully we can all log in with Gizmo using the login and password that we set up beforehand. The sub will have copies of the class code. If you need to reset that up, just choose a new password and a new username just to be able to complete the activity today. If you do happen to get done with the gizmo, the next thing that you can work on is your final draft of your lab discussion for the food calorimeter lab. Okay, that's my dog in the background there. The food calorimeter lab. Your final lab discussion is technically not due until Monday, but Dropbox is open and you've got the opportunity at this point to type some of that out and possibly get it done and checked off, and don't worry about it. If you get done with those 2 things, one of the next things that you can do is you can work on your 4C study guide, which you should have from the other day. Anyone who was absent the last time that I saw you should make sure to check your eChalk email. You can print off the study guide from eChalk as well as some of the math problems that we did in class together. So if you were absent last time, check eChalk and you can print off the 4C study guide from the last time. If you got the 4C study guide done, you also can study for your test. And we listed out some ways to do that. You can go back through the notes. You can do Quizlet online. You can go back through your study guides. But be forewarned, these are the appropriate things that you should be working on in the computer lab. It's not playtime. It's not free time to do whatever you want to or check in on the day's news. The sub has been instructed that if you are not following directions, you get a warning, and then you're going to have your computer shut off and you lose computer privileges for the rest of the block. So usually we don't have problems, we don't have trouble, but if you stay on task and stay focused, then hopefully we can get a lot done. And if you have any questions, please let me know. Again, on Monday, before we take the test, we will get a chance to see the solutions from some of those tougher math problems. We also will answer any questions that we may have on the 4C study guide before we take the test. So for Monday, what you need to make sure that you have done for homework is you need to make sure that you have your 4C study guide completed. Okay, I will check that off before we take the test. You also need to make sure that you study for the test, because that will be Monday. And the last thing, like I said, is that your lab is due on Monday to Dropbox by 11:59. So I'll remind you on Monday in class as well. And as always, if you have any questions, please let me know and behave yourselves.